quick addendum. I got up to my 15-minute limit and wasn't able to work this comment in. We get a straight line through the origin. Looks like that straight line, based on what we have here, ought to have a slope of 1, because we have 1, 2, 3, 4, 5, 6 here, 1, 2, 3, 4, 5, 6 here. But remember, this is scaled in units of the midpoint of the first trapezoid. We don't know what the scale is of our forpling graph, but if we could scale it in almost any way. So the forpling graph is not necessarily scaled so that the midpoint of the first trapezoid is at 1 of any kind of unit, nor is it scaled in such a way that the slope of the first trapezoid would be 1. Okay, so for example, if the forpling graph was scaled, well, again, the first slope could be anything. For example, perhaps the first slope could represent 0.792 meters per second squared. No reason it couldn't. I don't know why it would, but in certain circumstances it certainly could. And the first midpoint could be anything. For example, it could be 4.73 years. And that would not result in scale here, where the slope is in meters per second squared per year, or the midpoint in years, would not give us a slope of 1 in that system of units. Okay, so our straight line doesn't have slope 1, unless perhaps it does. Okay, and I don't know that I got that little bit down there. Okay, of course it could if the units were exactly right, but it'd be unlikely that in any observation of any interesting system we would actually have 1 unit here, or that this unit would be 1 and this unit would be 1, or that this unit and this unit would match in any way. To apply the forpling graph to any kind of a real-world situation, we would have to determine just what the units of the graph are, and of course we see that in the process of scaling the graph, which we might or might not have seen at this point. If you haven't seen the idea of scaling this graph, then that's something you'll understand soon. If you've already seen it, then you know what I'm talking about.